In October 2025, the celestial stage will be graced by two extraordinary visitors, neither hailing from our solar system. The first, christened 3I Atlas, is an interstellar drifter, its otherworldly green radiance casting an ethereal glow. The second, Swan R2, is a comet that has rapidly intensified and grown an unusual tail, challenging the norms of comets from our own cloud. The simultaneous presence and trajectories converging on the Sun have astronomers re-evaluating the mathematical improbability of such an event. As 3I Atlas approaches, its spectral analysis reveals a chemical signature that defies the rules of stellar formation, carrying diatomic carbon and cyanogen molecules that generate a green glow when stimulated by solar radiation. Swan R2's rapid brightening suggests a composition unlike typical comets from our own cloud, challenging decades of comet science. However, as both objects plunge deeper into solar glare, Earth's viewing geometry becomes increasingly challenging, and our ground-based telescopes will lose the ability to track them during the most critical phases of their encounters. Part 1. 2 stars in the night. Two travelers have graced our solar system, one slender and swift, tinged with an otherworldly green luminescence, the other sprawling and brilliant, unfurling a tail that spans degrees of sky. They hail from different corners of space, yet here they are, converging on our Sun in a cosmic ballet that has astronomers double-checking their calculations. The first visitor, 3I Atlas, made its debut on July 1, 2025, in the digital eyes of the Atlas Survey telescope in Chile, a single pixel of light that shouldn't have been there. Within hours, orbital mechanics revealed the truth. This object, designated 3I-less, was moving on a hyperbolic trajectory, not bound to our Sun. An interstellar wanderer, the third confirmed visitor from beyond our solar system's edge. The second appeared just months later, emerging from the solar glare like a ghost materializing at dawn. Comet C 2025 R2, discovered in Swan imagery on September 11, 2025, was already bright enough for binoculars, already sporting a tail that amateur astronomers were calling magnificent. Part 2. Instruments that whisper. The discovery of cosmic visitors begins not with a dramatic moment of revelation, but with the patient accumulation of photons on silicon sensors scattered across our planet. Each night, automated telescopes scan predetermined patches of sky, comparing each night's observations against catalogues of known objects to identify anything that moves too fast or in the wrong direction. The Atlas survey that found 3I Atlas operates 4 telescopes spread across 2 continents, each equipped with cameras capable of monitoring vast swathes of sky simultaneously. Every clear night, they generate hundreds of gigabytes of data, millions of stellar positions measured to extraordinary precision. The discovery of an interstellar visitor emerges from this flood of information as a single anomalous point of light that moves too fast and in the wrong direction. Part 3. Trajectories of Fate. 3I Atlas and Swan R2 follow completely different trajectories and orbits, yet their closest approaches to the Sun within weeks of each other defy the odds. 3I Atlas will make its closest approach to Mars on October 3rd, passing within 30 million kilometers of the red planet. Swan R2's closest approach to Earth comes later, on October 21st, when it will pass within 0.27 astronomical units of our world. This timing raises eyebrows among researchers who have spent their careers studying these celestial wanderers. Part 4. The Language of Metals. Deep space speaks in the vocabulary of atoms, and 3I Atlas tells us a story written in an unexpected dialect. When the Very Large Telescope turned its powerful spectrographs toward this interstellar visitor, it discovered nickel vapor glowing in the near vacuum around the comet's nucleus unaccompanied by the iron signatures that typically occur alongside it. This chemical peculiarity has spawned numerous theoretical explanations, each attempting to reconcile the observations with known physics. Part 5. Two Paths. One Dance. The trajectories of 3I Atlas and Swan R2 extend far beyond their orbits. 3I Atlas approaches from the direction of the constellation Serpent's Corda, travelling retrograde relative to the planets. Swan R2 appears near the constellation Virgo, emerging from the solar glare. The timing convergence of their key milestones creates a cosmic schedule that reads like someone planned it. If these were random events distributed uniformly across time, the probability of such tight temporal correlation would be extraordinarily low. Yet, statistical mechanics also teaches us that extremely unlikely events become virtually inevitable given sufficient time and sufficient opportunities. In a universe containing billions of comets and occasional interstellar visitors, perhaps we're simply witnessing one of those rare moments when the dice roll in an unexpected pattern. Part 6. Theories laid on like constellations. Human minds are pattern-seeking machines, evolved to find meaning in chaos and purpose in randomness. When confronted with two cosmic visitors arriving at our sun within weeks of each other, displaying unusual characteristics and following trajectories that seem almost choreographed, those minds begin constructing narratives that extend far beyond what the data actually supports. These stories range from the merely exotic to the frankly extraordinary, each offering a different lens through which to view the October 2025 convergence. Part 7. Strange Colors and Strange Chemistry. The universe paints its stories in wavelengths of light, and 3I Atlas has been creating a masterpiece in green since its discovery. As this interstellar visitor approaches our sun, its nucleus heats up and begins releasing frozen gases that have been locked in ice for millions of years. But the palette emerging from this cosmic artist doesn't quite match the colours we expect from objects born in our own solar system. The green coloration that has captivated observers worldwide emerges from a complex interplay of chemistry and physics occurring in the near vacuum around the comet's nucleus. Part 8. The Mars Flyby. October 3rd, 2025 marks a cosmic appointment that has been millions of years in the making. On this date, 3I Atlas will sweep past Mars at a distance of approximately 30 million kilometers, close enough for the red planet's fleet of robotic explorers to turn their instruments toward this interstellar visitor and potentially gather the most detailed observations we may ever obtain of an object from another star system. Part 9. Swan R2, the New Giant. While 3I Atlas captured attention as an exotic visitor from interstellar space, another cosmic traveller was quietly preparing to steal the show. Comet C-2025-R2, better known as Swan R2, after its discovery in solar and heliospheric observatory data, emerged from the depths of our own solar system to become one of the most spectacular cometary displays visible from Earth in recent years. Part 10. Technical speculations, engines, shields, and orbits. The line between the exotic and the engineered often blurs in the realm of speculative astronomy, where unusual observations can inspire extraordinary theories about what might be possible. In a universe filled with intelligence we have yet to recognize, 3I Atlas and Swan R2 display characteristics that, while explainable through natural processes, also invite consideration of more provocative alternatives, if only as thought experiments in the physics of directed motion and controlled energy release. Part 11. Shared Purpose. What could they have in common? In the theatre of space, coincidences become conspiracies and timing transforms into choreography, when human minds attempt to find patterns in the cosmic chaos surrounding our small world. Two visitors arriving within weeks of each other, displaying complementary characteristics and following trajectories that converge on our sun during the same narrow window of time, will begin to look less like random encounters and more like coordinated elements of some larger design. Part 12. The Relay Hypothesis, a cosmic data drop. Imagine 3i Atlas as a data courier arriving from interstellar space, carrying compressed archives of observations gathered during its long journey through our local galactic neighborhood. Its modest size and nimble trajectory suggest optimization for speed and maneuverability rather than bulk data storage. Yet even a small object could contain vast amounts of information if encoded using sufficiently advanced storage technologies. Swan R2, emerging from our own solar system's outer reaches, presents the complementary profile of a data center designed for processing and relay operations. Part 13. The Harvest Scenario, Fuel Fields and Fires. Imagine 3i Atlas and Swan R2 as components of an automated harvesting operation arriving at our sun, not by coincidence but according to patterns established long before human civilization emerged from African savannas. The smaller object functions as a surveyor and coordinator, measuring stellar output characteristics and plasma conditions to optimize collection efficiency. The larger installation deploys collection systems disguised as natural cometary activity, siphoning energy and materials from our star's outer atmosphere, using technologies that operate at the intersection of engineering and physics. Part 14. The Warning Signal, a cosmic SOS. As 3i Atlas and Swan R2 converge on our sun, their combined presence could serve as a warning signal, a cosmic SOS sent from a distant civilization seeking to share their technology and knowledge. The data they carry could hold the key to harnessing the energy of stars, solving the energy crisis that threatens to engulf our own world. Or perhaps the visitors are simply curious, driven by the same unquenchable thirst for knowledge that fuels our own species. Part 15. The Arrival, a New Dawn for Humanity. The October 2025 convergence of 3i Atlas and Swan R2 represents more than just a remarkable cosmic event. It presents an opportunity for humanity to take a giant leap forward, to learn from the wisdom of those who have journeyed across the vast expanse of space, to share their knowledge with us. Whether these visitors are harbingers of a new era of interstellar cooperation, or mere curiosities from the cosmic zoo, their presence serves as a reminder of the vast potential that lies within our grasp, provided we have the courage to reach out and seize it. Part 16. The Legacy, a Cosmic Epilogue. The legacy of 3i Atlas and Swan R2 will extend far beyond the brief window of their presence in our solar system. Their arrival will inspire generations of scientists and engineers to push the boundaries of what is possible, to dream of new technologies and new frontiers. It will challenge our understanding of the universe and our place within it, forcing us to confront the mysteries that have long haunted our species. And perhaps, in the end, it will remind us that we are not alone, that there are others out there, watching and waiting, eager to share their knowledge with us. Part 17. The Future, a Cosmic Odyssey. As 3i Atlas and Swan R2 continue their journey through the cosmos, they leave behind a trail of questions and possibilities, a cosmic odyssey that will captivate the imaginations of countless minds for generations to come. Will we be ready when the next visitors arrive, armed with the knowledge and technologies they have gathered from the farthest reaches of space? Or will we continue to squander our potential, consumed by the petty squabbles and short-sightedness that have plagued our species since time immemorial? The choice is ours to make, but the clock is ticking and the stars are watching.